All right.
Okay, welcome. So this is just some slides and some talks and looking at some sites about this idea of can we start leveraging some of our pen testing tools into Devsecops methodologies, like on a CICD pipeline. So these are ideas and techniques for testing application security. So some thoughts, right? If we can leverage tools like Jenkins, GitLab, Azure DevOps, and tie in tools that run in containers, we can manage red team whitebox testing in a similar manner to other developer tools to check code. Tie in this testing with tools like SonarQube, Synac, and Fortify, and you can reduce the overhead. All right, so we said a lot of words in there, so let's unpack that. First, let's talk about what whitebox testing means. When we say that, that's a form of testing where you will have access to the code base or full access to the application. You'll usually be part of an internal security team. And when we're talking about Jenkins and GitLab and Azure DevOps, these are tools that allow us to develop what are known as like automation pipelines or continuous integration and continuous delivery. And what those allow us to do is in a programmatic way, you can either write it in code or um, you'll click some buttons and fill in some forms. You have it in such a way that when you check your code into a source version control repository like Git, when that code is checked in, several steps are kicked off to make a quote unquote build of the software, right? So there are these tools like SonarQube and Synac and Fortify that are code scanners, right? They will look at your application and they will see like in the code in usually a static manner, how are they working? Okay, so what we're talking about here is how could we leverage that same sort of way, but in more of a more dynamic fashion? So this is a image from criticaldesign.net. This is their post about the power of DevOps automation. They have a talk and a video about it where they have some automated infrastructure using Jenkins that kicks off these tests through the web app attack lab or in their assume breach infrastructure using MITRE and Caldera framework and some other tools. So this is just sort of an image to kind of get that idea in our head, right? So we're talking about several different tools all working together in order to achieve a goal, which is testing the security of our application. So what started this looking at it for me? Well, I read a blog that Kali Linux now has containers, right? They have LXC and LXD containers, which are kind of like a Ubuntu style or Debian style container system. And then they also have Docker containers, and they are available at this website that kind of has a walkthrough of how to do that. So that really got me thinking about this idea of, okay, so if Kali has containers, I could start writing Docker files that would spin up minimal instances of Kali that are plugged into the Kali repos so I can pull down different tools. Like if I needed to pull down Nmap or Dirbuster so I can start testing the applications, I could do that. That's great. But how does this help with like more application security? Like there's a lot of web applications. So how do I test the security for those things? Well, it turns out Burp Suite can be put into a CI/CD pipeline. So Burp has a REST API that can be called remotely, right? So basically, we can make requests over HTTP to a Burp Suite Pro instance, and it can manually or automatically do Burp queries and do normal things that you would do with Burp, like take a URL that's in your proxy history, throw it to intruder, run some tests against it, throw it to repeater, try some more things, and so on. Most of the features within Burp can actually be called through the REST API. Right. So here's an example taken from this blog here, right? This is talking about how to leverage Burp within the Azure DevOps framework, which is like a code repository and a CI/CD pipeline system, right? So it's talking about if we load Burp Suite up, we can get Burp on a URL that's on port 1337, and we could set it to all interfaces, and we can set up API keys that will expose Burp so that we can integrate into it. Okay, that's great. So if we can put Burp in a Docker container, then we could put Burp into our CI/CD pipeline. So if we spin up a web application, we can start testing it. So that's what I'm talking about here, right? So you could create a Docker file that will expose Burp Suite, and you could combine that with Selenium, which is a automation testing framework that you can use in a variety of different languages like Python and so on, to actually test in an automatic way your web application. And you can do that on a, like, say, a headless browser, or you can do it on minimal instances of the browser so that you can kind of get testing into it. So Selenium is used with great effect for testing applications, web applications. So maybe you could leverage Burp with that. So before we look at that, on this same blog, I read that they have this entry here about combining Selenium and Jenkins together. Right. So what they're talking about here is that they have exposed the REST API. And so the REST API is now exposed, and they can do these different configurations. They can run scans. They can send URLs into the scanner. They can add things into the scope. They can add things to Intruder. So they're using Jenkins, right? So the testing goes in. The Selenium sets up a web browser, right? And then Burp can test against it. And in the pipeline, they've written a proof of concept against this web application that they have that makes calls through HTTP to their Burp instance that actually starts testing against it of anything that's been in their history, right? So that sounds great. And in the end, like with many of these CI/CD pipelines, they get output, right? So Burp Suite apparently with the REST API will put out this Burp Suite scanner report, and you can then leverage that inside of say Jenkins or your other CI/CD, so that a developer could get feedback, or a security team could get feedback automatically of what they're looking at. So I started doing a bit more research and a bit more thinking. And I'm moving back to the PowerPoint again. So there's also a framework called Caldera, which is developed by the MITRE Corporation, who actively contributes to the MITRE framework, which is kind of a way that of modeling attacker behavior in a way that's a little bit, that takes what the cyber kill chain, if you're taking any classes about ethical hacking, you might have learned about that takes that idea and that methodology and expands it into showing what adversaries might be using more in the real world. And this is an automatic framework that uses things like Atomic Red Team, which is made by the Red Canary Corporation, that leverages stuff that's in the MITRE ATT&CK framework in an automated way, so you can do security tests against applications or systems that you've stood up, like, small networked systems and things like that. But apparently Caldera also has a REST API. So that got me thinking, like, okay, could we combine all these different pieces together into our own CI/CD? Well, sure, right? We could start making our red teaming tools can all be code, right? We could store these configurations and these setups within a source version control repository, right? We could use a pipeline like in GitLab to use infrastructure as code to stand up the environment that we need in one part of a pipeline, right? Like build the base OSs, and then use configuration management, like what they were talking about before, how they were using the Ansible Tower. So Ansible Tower has a REST API that allows you to schedule when you want Ansible, which is configuration management, to go out and configure instances for you. So that got me thinking about this idea of, okay, so we could then have some kind of desired state configuration for our tools, right? We set it up first, right? Like we do some testing and we get it into a good state. And then we could wrap this all in configuration management and infrastructure as code so that we can build out our tools. And now we have things that can, right, reduce the overhead of a application security team or a pen test team, right? If we
is your audio still on, Dave? I'm not getting any audio anymore. Let me try to chat.
and
yeah, your audio is just not good. All right, so your audio is good now. Go for it.
So yeah, that's kind of my overall general idea. And in a future video, there's a couple things that I would like to kind of combine together. This idea of standing up my own ESXi instance, installing some of these tools, and then seeing how well that can be leveraged, right? There's like this article was talking about, there's all these different things out there like BWAP, right? Which is a vulnerable web app. All right, great. Well, I would like to see how feasible is it to configure these things and code these things into desired state configurations. And so I also wanted to show briefly where that Caldera was. This is developed by MITRE. They have documentation here about how to stand it up. And it has access to these different plugins that allow people to do different things with it, like create dashboards and visualize how applications are going. There's reverse shell functionality and a C2 framework, and so on. So that's kind of my thought. I think that if we really think about how can we be good security engineers and good ethical offensive security practitioners, we need to start bringing these manual processes, as they already have been by some brilliant people, into organizations. Because if, say, for instance, if a pen tester, if she can take what she's doing in a manual process on her engagements and then wrap that into a pipeline that the developer was using on their application, well, then they can repeat her results on a more frequent basis, right? And then her job then is she then also becomes a developer, because now she's coding her red team tools in such a way that each execution in each pen test is in itself as I'm saying, a desired state configuration, right? We have a state at which each tool is executed, and not this, we've thrown it together and it works and we're going to use it this one time, and then we're have to tear everything down, and then the next engagement, you got to spend all this time building VMs and setting everything up. So with that, I'm open for any questions, or if anybody from the audience wanted me to go back and like pinpoint a slide or something like that, please let me know.
Yeah, we're running up on time, Dave, but this is a really good presentation, and I completely agree. I believe this is the future, right? And then you touch on some really important concepts about how red team needs to sort of learn op, right? And they need to go through this process to automate and plug in into the development a pipeline, so you can get some very powerful regression testing and just a lot of the security testing as the development is taking place versus at the end of development. So this is all really good material, and I'm looking forward to your future presentations when you build up on this. So awesome.